6.6, solving exponential and log equations. We're going to focus on solving exponential equations. One property that you don't have to know the name of, but what it basically says is that if you have a situation where you have the same base, then the exponents have to be the same. And so sometimes it's hidden in the equation, such as this one. You can get both of them as base 10. So this would be 10 squared is 100. This is 10 to the negative 1. And then that's going to be times x minus 3. Now that you have the same bases, you can then say the exponents have to be the same, and I'll distribute through. Therefore, by adding x on both sides and dividing by 3, x is equal to 1. The other type of question looks like this, where you can't get the bases the same. So what I would do is change it to log form, because you're trying to solve for the exponent, and logs are exponents. So a couple ways of doing this. You could just think about that as the definition and say, okay, it's the log base 2 of 7 equals x. Or alternatively, you could think about it as taking the log of both sides. And when you take the log of both sides, you're going to see that you can do the power rule, which is x log 2 equals log 7. By dividing by log 2, you end up with this. Now, is that the same as what we had here? Yes, because the change of base law says that that is equal to that, which in turn they would be equal, and then you'd use your calculator and determine what those would equal. Choose whichever way makes sense to you, and stick with it. So the other type of question is this Newton laws of cooling, and I've seen this on AP Calc tests before. It basically says if you've got a pie or something and you take it out, what will the temperature be after a certain amount of time? And so in this particular problem, T is the ending temperature, T sub 0 is the beginning, T sub R is the room temperature, rate at which it cools, the time, and then we have the room temperature again. So we have a situation here where its temperature starts at 212, the room temperature is 70, you have a rate, and its question is how long will it take for it to get to 100. And so when you do this problem, you're going to know that we're talking about T in minutes. So the ending is 100 equals the beginning temperature minus the room temperature, e to the negative 0.046 T. T is what we're trying to solve for, plus the room temperature, which is 70. So doing a couple things here, I'm going to subtract 70 from both sides and get 30. And I'm going to do this subtraction and get 142. E. So now we've really simplified it quite a bit. And what you do have to do is get this 142 away from the E. So we're going to divide both sides by 142 and end up with this. At this point, we want to solve for my T. It's just the exponential on the right. So I'm going to switch the form by the definition and say that the exponent, negative 0.046 T, is equal to the natural log, because that's what the base is, of 30 divided by 142. And at this point, we want to divide by negative 0.046. And then we grab the calculator and let's see, natural log of 30 divided by 142 times 1 divided by negative 0.046. And that should give me the amount of time in minutes, which means the time is approximately 33.79 or 80 minutes. It was 33.796, rounded up 33.8 minutes to reach the specific temperature.